For decades, scientists and science fiction writers have wondered what humanity's first contact with alien life might look like. Hollywood often imagines invading aliens or wise extraterrestrial mentors. But what if the truth is darker? The first alien civilization we detect might actually be one that is collapsing, sending signals into space during its final moments. This idea, called the eschaton hypothesis, suggests we may discover not the most advanced civilizations, but the loudest before they disappear. A lesson from the history of astronomy. To understand why this idea might make sense, we can look at how many major discoveries in astronomy were made. Throughout the history of space science, some of the most important discoveries have occurred when astronomers detected entirely new types of cosmic phenomena. One notable example is the discovery of exoplanets, planets orbiting stars outside our solar system. Before astronomers successfully identified exoplanets, scientists already suspected they existed. However, early searches were guided by assumptions based on our own solar system. Researchers believed that gas giants like Jupiter would typically orbit far from their stars, where temperatures are low enough for ice and gas to accumulate during planet formation. As a result, the first instruments designed to detect exoplanets were optimized to find Jupiter-like planets in wide, distant orbits. But the universe had other surprises in store: pulsar planets and hot Jupiters. The first confirmed exoplanets discovered in the early 1990s were not orbiting ordinary stars at all. Instead, they were found around pulsars, the dense remnants of exploded stars that emit intense beams of radiation. These environments seemed incredibly hostile for planetary systems, yet planets existed there. Soon after, astronomers began discovering planets orbiting normal stars. However, many of these worlds were again completely unexpected. These planets, called hot Jupiters, were massive gas giants orbiting extremely close to their stars, sometimes closer than Mercury is to the Sun. These planets reach temperatures of thousands of degrees and complete an orbit in just a few days. For decades, scientists believed such systems should be rare or even impossible. Yet early observations kept revealing them again and again. Why? The answer lies in a concept known as detection bias. Why we see the loudest signals first. Detection bias occurs when certain objects or events are easier to observe than others, causing them to appear more common than they actually are. Hot Jupiters, for example, are now known to exist around less than 1% of stars. Despite their rarity, they dominated early exoplanet discoveries because their signals are much easier to detect. Their massive size and tight orbits create large, measurable effects on their host stars. In other words, they were simply too obvious to miss. The same pattern appears throughout astronomy. Giant stars and the illusion of abundance. On a clear night, thousands of stars are visible to the naked eye, and surprisingly about 1/3 of them are giant stars nearing the end of their life cycles. Yet in reality, only about 1% of stars in the galaxy are giants. They dominate our view simply because they are extremely bright. Giant stars can be seen from vast distances, while smaller stars remain invisible unless they are very close. For example, Deneb is visible from about 2,000 light-years away, while Proxima Centauri, the closest star to the Sun, is too dim to see without a telescope. In astronomy, what we notice is often determined by brightness, not abundance. Rare but impossible to ignore. Another striking example comes from supernovae, the explosive deaths of massive stars. The most common type of supernova occurs when a star with more than 8 times the mass of the Sun exhausts its nuclear fuel. Without the outward pressure from fusion reactions, gravity takes over, causing the star's core to collapse. The outer layers then rebound in a colossal explosion. For a brief period, a single supernova can shine brighter than all the stars in its entire galaxy combined. Despite their immense energy, supernovae are extremely rare. In a galaxy the size of the Milky Way, one occurs roughly every 50 years. Yet astronomers detect thousands of supernovae every year. The reason is simple: they are so luminous that we can observe them across enormous distances, sometimes from the far side of the observable universe. Once again, the most detectable phenomena are often the most extreme and unusual ones. Applying the same logic to alien civilizations. The Eschaton hypothesis applies this idea to the search for alien intelligence. Many extraterrestrial civilizations might be stable and sustainable, carefully managing their energy and environment, which would make them extremely difficult to detect. Highly advanced societies could even become so efficient that they blend into their surroundings. As science fiction writer Carl Schroeder suggested, any sufficiently advanced civilization is indistinguishable from nature. However, unstable civilizations, those experiencing rapid technological growth, environmental disruption, or catastrophic events, could produce powerful signals that travel across the galaxy and make them far easier to detect. When civilizations become loud. A key concept in this hypothesis is disequilibrium. For most of their existence, civilizations may remain relatively balanced with their environment. Energy production, technology, and ecological systems exist in a stable relationship. However, when that balance breaks down, dramatic changes occur. A civilization undergoing rapid growth, extreme technological development, or environmental collapse could produce massive energy outputs, waste heat, unusual atmospheric chemistry, or powerful bursts of radiation. These signals could make them far more visible to distant observers. Earth itself may already exhibit such signs. For example, human-driven climate change is altering the chemical composition of our atmosphere and affecting global temperatures. From afar, these changes might be detectable as an unnatural atmospheric signature. But even more dramatic signals could occur. The ultimate signal. Imagine a civilization destroying itself through nuclear war. If every nuclear weapon on Earth were detonated at once, the planet would release enormous amounts of energy into space. For a brief moment, our world would become dramatically brighter and easier to detect. Astronomers might observe such an event across interstellar distances. In 1971, astronomer James Elliott even proposed detonating nuclear devices in space as a way of announcing humanity's presence to the galaxy. While the idea was controversial, it illustrates an important point: catastrophic events generate signals far stronger than ordinary activity. Just like supernovae, these signals may be brief, but extremely visible. Why loud civilizations are easier to detect. The detectability of a civilization increases rapidly with its energy output. If a civilization becomes 100 times more luminous, the region of space in which it could be detected expands dramatically, potentially making it thousands of times easier to observe. This means that short-lived but intense phases of instability could dominate our observations. Even if quiet, sustainable civilizations are far more common, their signals may be too subtle for us to detect with current technology. Instead, we might notice the rare civilizations that suddenly become extremely loud. The tragic implication. If the Eschaton hypothesis is correct, humanity's first contact with extraterrestrial intelligence may not be a joyful moment of discovery. Instead, we may detect a civilization during its final moments. Perhaps it is broadcasting desperate messages into space after realizing its impending destruction. Perhaps its technology has triggered environmental collapse or war. From our perspective, we would be observing a cosmic disaster. Just as astronomers watch distant stars explode as supernovae, we might witness the last signals of an alien society. Such a discovery would be deeply unsettling, but also profoundly important. It would serve as a warning. A possible solution to the Fermi paradox. The Fermi paradox asks a simple question. If intelligent life is common in the universe, why haven't we seen any evidence of it? The Eschaton hypothesis offers one possible answer. Many civilizations may become quiet and sustainable, making them nearly invisible to distant observers. Others may collapse during chaotic periods that briefly produce powerful signals before disappearing. If this idea is correct, scientists should focus on detecting short-lived, unusual events rather than steady signals. Modern surveys like the Vera C. Rubin Observatory, which will continuously scan the sky for rare cosmic events, may help us detect exactly these kinds of fleeting signals. Listening for the loudest voices in the cosmos. For centuries, astronomers have made breakthroughs by watching for the unexpected. Strange signals, unusual objects, and rare cosmic events have often led to the most profound discoveries. If alien civilizations exist, the first one we detect may not be the most advanced or the most peaceful. Instead, it might simply be the loudest voice in the cosmic darkness, a civilization shouting into the universe during its final moments. And in that desperate signal, humanity may glimpse not only another world's fate, but a possible future for our own species. What do you think? Could the first alien civilization we detect actually be one in its final moments? If you enjoyed exploring this idea and want more fascinating mysteries about space and the universe, make sure to like and subscribe for more videos like this.